All right. That'll be up in a second. Mostly, we're going to wrap up the lab today, which means the majority of time, you're going to stand in line waiting for the scale to be done. So go pretty quick. So when you get here, have your thing all ready to write down. Don't do any math right here. Just find your measurement and then get out of everyone's way. You okay with that? The things you're going to measure are the two-way boats with the dried liquids in them. That sounded stupid, but you know what I meant, right? Okay. If you didn't label them very well, the one that looks sort of crystalline is your citric acid. The shiny one is your sugar. And then you can mass your just whey boat. It's dry, so you can just put the whey boat in here with the substance on it. You with me? The whey boat goes right in the garbage. Your other whey boats that are sticky, I'll put some scrubbers back by this and some hot water. You got to scrub all the sugar off and the citric acid off when you're done. I'll put a strainer there also to let them dry. Okay, in red, I don't even know why I typed the test to be tomorrow because I knew we wouldn't get there, but whatever. It's going to be Tuesday now. So lab wrap up, sig figs. Now, all the calculations and stuff, I'm not going to give you class time really to do that. As soon as the last person's done measuring, we should be fine. Now, the first people measuring, they'll do all their calculations while everyone else waits in line. So it's not the best scenario today, but that's what we got. So you know you're successful when you can or have done these things, measured all the masses, washed them, and then this is the significant figure stuff that we talked a tiny bit about. We'll carry on with that. Okay, so you're going to do a lab report with this information, and you each need to turn one in. It's okay if all three of their lab reports look super similar, but you need to at least submit 3 different ones on Canvas so I can grade your name. So it doesn't look like a 0 if you're with me. If you have stuff here, that's fine. Just attach it to the assignment, right? I would like a typed document, but you don't have to retype a table and a flow chart or anything like that. Just attach it as the image. Thumbs up. I want an intro. I want what you did, what you got, sources of error, and then we'll do some percent error calculations as well. Eventually, I'll tell you what you should have gotten. Okay, find your things, weigh them, and we'll get things going. All right, so what we did here, you should now have your masses at the end, correct? You have to do some math with those numbers. Is everyone aware of that? So I'm going to pretend my original sample was equal to 10 grams. Now yours was nowhere near that, so don't copy this. But I want to know the percent of sugar. So how would I figure that out? All right, so I take the grams of sugar. Whoops, I didn't mean to put a slash yet. Of sugar divided by the total grams of the original thing you weighed 2 days ago. So let's pretend I got 3.85 grams of sugar. I'd put that right here. I'd divide it by 10 and multiply it by 100. And then I would say that the sugar made up 38.5% of the mixture. We okay with that? Okay, why don't you take 2 minutes, if you haven't already done that, and calculate the percent for all 4 things. It's a nice truck. You guys already got them? Or is she doing it for everybody? Okay. Okay, about another minute.
This is like the last time. Yeah, don't write the fourth digit because that's like
All right. So now, let's wrap it up. How many of you have all four of your percentages? Okay, no. You're going crazy mode. How many of you have negative mass that you recovered? Anybody? I know we had at least one group that had negative right here. That's not uncommon. It's cool. You broke the law of conservation of matter. Congratulations. It happens. All right. Now, part of this lab is to calculate your percent error for each one of them. These are the values in a perfect world you should have gotten. These are the actual or the accepted values. Now, usually you're really far off. So you're like, man, I am a failure at everything. Well, that might be true, but don't use this data to support that hypothesis. Okay. All right, that was rude. You're probably amazing and all 4.0 genius and beautiful people. Anyone willing to tell me, these are dashes, by the way, not negatives. Maybe I'll put an arrow here. Anyone willing to tell me what they got for their iron? Go ahead, Blaine. 4%. All right. So this would be the observed value. Have we done percent error in this class yet? Okay. We're going to do it now. So to find your percent error, you take what you got, that's the observed value, and you subtract what the actual value should have been. So I'm going to take 4 and I'm going to subtract 10. And then I still do more. So I take the observed minus the accepted and I divide it again by the accepted and I multiply that all by 100 to make it a percent. All right, and what do you end up with? 60% error, right? Okay, and you're like, man, I bombed that. I've had tens of thousands of percent error before in this class, so don't feel bad about 60% error. All right, so you would repeat this process for each one of them. Now, I should say this was negative 60% error. I'm really bad at focusing on the sign. Why would it be a negative? Because he got less than he should have. All right. Now, some of them will be negative, some of them will be positive. But will you now do that for each one of your percentages? It's observed minus accepted divided by accepted times 100. That's not bad. -20 is not bad. %14 error. That's pretty good. Hey, 916, that's impressive. Yes, ma'am. It's fine. You got error on your error. Nice. That's okay. That's upper level error. Okay, take about another minute and a half and see if you can calculate those. If I'm going too fast, you just have to do them at home. You all right, Sky? You okay?
Yeah.
Okay.
Just trying to find out.
Does anyone have an error on anything that's less than 10%? Not a single soul. Four. So your error was 2. Or was that your percent error?
That was our percent.
All right. You're still having some debates, so I'll give you another minute or two. Might as well go get more caffeine while I'm at it. What? All right. I would love to wrap this up in about, it's okay, a minute. All right. So one more time. Good, or a question? Okay. Let's talk about this lab report. I don't expect it to be even remotely perfect data, but I want a decent report. So intro, and then tell me what you did. That's called your procedures. Your procedures. All right, then your data. And that could be like all this stuff right here. Your percent error, well, so your masses, your percent compositions, and your percent error. Something like that. It doesn't have to be exactly like this, but I want that type of information. All right. And then I want your sources of error. And then just some sort of short conclusion. Your sources of error and your conclusion, I'm fine if they're in the same section. But your conclusion is where you would restate, we had these percent compositions. We had some errors, they were this. Our percent errors you can see in the table or whatever you feel like. Don't make it a novel, don't make it perfect. But I need it to be at least something I can follow. Okay with that? Yep. That says intro. It just says intro. What's that? In this lab, we were asked to separate 4 substances from a mixture, and we were given these materials or something like that. This one I want typed. But if you want to attach that table, then just submit that, say like see attached or something. I don't want you to spend 3 hours on that. Yeah. Okay. Now, how many had a lot more chalk than you should have? Raise your hands. Okay. Typically speaking, everyone has more chalk than everything else. Well, why? Tell your partner why. Okay, Sky put it perfect right before I walked away. She said, because that's the stuff we don't filter out and everything's just stuck in there. Is that about what you said? Yeah. So if you think about the chalk, it probably still has what in it? Sugar and citric acid. If your sugar and citric acid were low, it's because it's still stuck inside the chalk. So how could we have fixed that? We could have put more liquid in. Okay. We could rinse that with a gallon of methanol. Then I promise we'd have all the citric acid out. A gallon of hot water, I promise we'd have all the sugar out. Now, it would take 3 weeks to dry, but we would have been extremely thorough. So it's not really a failure of you. It's just a failure of the process, the speed at which I want you to do the process as well. So there's some reasons there for your percent error issues. Okay. Any questions on my expectations? Let me remind you real quick. I don't think any of those. So this, you'll submit it on Canvas. And then I did add something else I want you to do. It will take you 7 minutes. Okay, the mixed up mixture lab. See that right here? In chapter 1, essential ideas, Mix Up Mixtures lab report. That's where you'll submit that. And that's due on Monday. So you have the weekend to do it. Okay, I added something I want you guys to look at. I have no idea how it looks on your end. So will someone open up their device and see how it looks on your side? It is the Significant Figures EP. EP stands for Edpuzzle, which stands for kids don't like them because you can't fast forward. Okay, not funny. I've always assigned this, but I've done it outside of Canvas. Will someone open up Canvas and look at what this looks like on your device? If I do student view, it just says I'm not authorized to access that thing. So that's usually I can, but this one gives me a dumb message. Now, I believe if you have a phone and you do this on it, I've read, you have to have the Canvas app to access it or the web, and you have to have the Edpuzzle app. I would do it on a computer if you have one. But do you have it open on your Canvas? Anyone? You do? Perfect. Let me see what it looks like. Oh, I'm not that skinny. Okay. So on your phones, it says open in app. The app is the Edpuzzle app. 4 years ago, kids hated that app, but hopefully it's been updated. What Edpuzzle is, it's a video that is linked to questions. And it forces you to watch the video and then answer the questions at certain times. It is for your benefit. It's only a 4.5-minute video. There's like 5 questions. They're not super hard. So if you'll start working on that, that'd be awesome. Okay, let's talk. What we're going to talk about is definitely supported by this stuff. So the rest of the hour, we're going to talk about significant figures, how to determine how many of them there are in a given value, and how to do math with them. Now, you do not have to do this, how this slide is written. This is just a note-taking tool that I have found useful in my life and useful in AP chemistry. It's up to you, but they're called 2-column notes. Has anyone ever heard of 2-column notes? Just old people. Yep, I just threw you into old people column. You have? Okay, and a not old person. 2-column notes. When you do AP chemistry, there'll be a lot of times where you do practice problems based on a little section of notes. This is one way to organize them, where you put your notes on the left and you do your sample or examples or practice problems on the right. You do not have to do it, but 2-column notes is a really good way to keep track of information and practice problems at the same time. It's up to you, but I like to just kind of demonstrate this on this particular subject. I don't teach 2-column notes. It's just a piece of advice here. Okay, this slide is extremely important, like to get a good score on your AP tests, because you have to report your answers with correct significant figures. So here are the rules for determining the number of significant figures in a given value. So in these rules, the first one is that all non-zero digits are significant. So what we're doing right now, you'll just get a number and it will ask how many sig figs are in each number. So we have 581 right here. As you look at 581, the first thing you would say is, are there any zeros in that number? No, correct? So if there are not any zeros, then the 5 is significant, the 8 is significant, and the 1 is significant, which means this number would have 3 significant figures. When I grade your test, you'll have a number, and sometimes I'll just put like a -1 SF. That means you didn't get it wrong, but you missed a point for the wrong significant figures. Now I take it out of 10, so you still got 90% correct, but who would rather have 100 than 90? All of us. So don't do all that work and miss a point. It's like missing the head check on the way out of parallel parking. You did everything hard and now you're just dumb. Okay, so here we go. Anything that's not a 0 is always significant. There are 3 significant figures in this number, the 5, the 8, and the 1. Okay, zeros between 2 significant figures are themselves significant. These are often called sandwiched zeros. All right, so we have 100.5. So in this example, since there are zeros between 2 non-zeros, we would count them as being significant. So in 100.5, this would have 4 significant figures. Okay. Now, a lot of this process we're doing, it has to do with how we write the number in scientific notation. So this top one, if we put it in scientific notation, would be 5.81 times 10 to the second power. We would include all 3 of these when we wrote this value. Okay with that? This one would be 1.005 times 10 to the second. Okay. Zeros at the beginning of a number are never considered significant digits. They're just helping you know how many places you go over before you start a value, but they are not considered significant. So in this value, none of these count. We would end up with 3 significant figures here. And if I were to write this in scientific notation, I would include the 5, the 7, and the 8 because they are significant. I'd say 5.78 times 10 to the negative 1, 2, 3, 4, 5, 6. So those zeros, it's not like they didn't exist, they matter. They helped me to find the exponent, but they're not written in this. I wouldn't say it's 0.578 times 10 to the negative 6. That'd look weird. That'd be super weird. All right. Now, this is usually kids are fine. This is the one that gets confusing. Zeros at the end of a number are significant if a decimal point is written in the number. But if there isn't, then they don't matter. So we have 1200 versus 1200 with a decimal at the end. So this number right here, this would have 2 significant figures. But this one would have 4 significant figures. If I were to write them in scientific notation, this would be 1.2 times 10 to the third. You're not going to like this. You're like, well, is this really that big a deal? Well, it is in this class. This would be 1.200 times 10 to the negative third. Now, do you remember our talk about everything we know and a guess? It has to do with how accurate we know it, the value, and how precisely we can repeat it. So if I look at this as a viewer, I know that this is not a very accurate measurement. I know that the 200 was the estimate. So whatever they measured, I know it's past 1,000 and about 2/10 past, but I don't know exactly. Here, I know all 4 of these. This number was my guess. So I know it's 12,000 and then it's got to be in the low zeros or tens places, I should say. So I would know this number is 12,000 and about 0 or 1 or 2. I know this number significantly more accurately than that value. Okay, these are the 4 rules that everything, why aren't you scrolling? There we go. Everything we do will be run through first. So let's look at the next slide. So will you try A, B, C, D, and E on your own for a minute? And then compare A, B, C, D, E to your partners. So all I want to know is how many significant figures are in each number. Not going to practice. It's trouble. I don't force you guys to do notes, but really there are some times you definitely should write some stuff down. Okay, check with your lab partner now. Yes. At the end, yes. But only if there's a decimal. Yes. Okay, let's wrap it up. So here we go. Does anyone feel extremely confident about their answer to letter A? How many? 4. How many of you agree with that? Uh-oh. Okay, well, yeah, that is not right. We can still be friends though, right? You don't want to be my friend? That's good. Abigail, it is 3 significant figures. Anything before a non-zero, we cross out. And then it's everything after. 3 significant figures. Okay. After, look right here. The zeros at the end of a number are significant if a decimal point is written in the number. Anywhere in the number, the 0 at the end will count. Zeros at the start, do they ever count? Never, ever, 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 ever. Okay, so we had 3 right here. Anyone very confident in B? Go ahead, Blaine. 4. 4 is the correct answer. Why do these 2 zeros count? Tell your partner. What's the indicator that they matter? It has a decimal. Decimals make everything more complicated. We learned that in 4th grade, right? Like, why do I have to do this math? Okay, letter C. Does C have a decimal? Payne, how many? It only has 3 significant figures. The difference here, there is no decimal, so the numbers at the end they're not considered significant. I shouldn't say they don't matter. They're placeholders, but they're not considered significant figures. How many had that one right? Okay. Letter D, 6.00. Everyone, what do we get? 3. 3 significant figures. My S's are struggling today. All right, because there is a decimal, so these count. And then E, how many? Just 1. So this would be the least accurate. So far, okay? Okay. Why do we do this again? That's a really good question. We do this so we don't ever overstate the accuracy of what we actually know. And now, why do we really care in science? So we don't blow stuff up or kill anyone. We need to be really accurate when we make scientific measurements. Okay, if you can, will you scan this as quick as you can? If you can't do it, it's okay. I apologize. You can type the whole thing in the bottom, but that's so 2015. Yeah. Uh-oh, this school service up here is pretty bad. All right. If it worked for you, it's a significant figure practice website. It's really old school. Like this was cutting edge when I was in college, but it works. So you hit new problem, and then it gives you this value. Determine the number of significant figures in 2.0 times 10 to the 7. I don't really care about that. I care about the 2.0. So how many sig figs are in 2.0? 2. So you would enter your answer here. Does this work on a phone? It works on some phones. Okay, I heard a no and mostly yeses. So you'll get a different value probably, but I would put a 2 right there. Maybe. Then I would hit check answer, and I'd see that I was correct. Total done, total correct. You hit new problem. My challenge for you awesome nerds tonight is to see how big your total correct streak can get. It's not homework by any means, but it's something that you can go. If you get in the 10s, 15s, 20s, you probably know what you're doing. All right. If you don't want to do that, that's fine. This is just an opportunity. Whoa, that is really weird looking. All right. I've never seen that problem before, but it's just an opportunity for you to practice. So look here, 0.0094476. How many sig figs in this problem? 1, 2, 3, 4, 5, 6. You with me? Man, that looks terrible. I am sorry it looks that way on your phone. I have no idea. Okay. Androids versus Apple. Okay, it looks like it works okay on Apple, but the Android screen's having an issue. Okay, tonight, that video I said I would tell you, but then I did it, and I said we watched today, and then we didn't. It's right here, it's on the group meet, and I'm gonna right this second, I'm gonna copy and put it in an announcement. So Haley doesn't have to text me.
So what's it all about with significance?